Okay, welcome to another video. In this sequence of videos, we're going to be covering section 10.1, which is about circles and parabolas. Now, in our class, we really only care about the circles part of this. You don't need to worry about the parabola stuff. We've already done some stuff with parabolas. And you don't need to do any of the stuff on parabolas in this section. So we're just going to look at the circle stuff. This is actually the last section of material for this class. So that means after this, you're basically, we're done with new material, which is really exciting. This is the last one. You just have to hang in here for this one, and then you are done. Okay, so let's go ahead and get into it. 10.1 is all about circles, and really there's just one equation that will help you when you're dealing with circles, and that's what we're going to be looking at in this first video, and kind of motivate where it comes from. So let's look at a circle. Okay, so I'm going to draw a graph here, and I'm going to try and make it pretty big so that I can label things really nice on this graph. Well, a circle is a set of points, right, that's round, and how you can kind of formally mathematically define it is if you take a center point. I'm going to say my center here is at 0, 0, okay, for now. And then I'm going to have a kind of, if I drew out the same distance, I'm going to see if I can get a like pen here or something. If I took the same distance away from C, the center point, all the way around, notice what happens as you move this around. Well, it traces out a circle, right? All the way around. Now this pen is kind of long for this graph, so I'm going to do a slightly shorter radius. Let's maybe do a radius of, we'll do like 4, okay? 1, 2, 3, 4, okay? So if I go 4 away from the center, 1, 2, 3, 4, and 1, 2, 3, 4, okay? 1, 2, 3, 4. So I'm going 4 away from the center every way I can. When you do that, and even if you do that out for other values, it's going to trace out a circle. Okay. Whoa, there's my beautiful circle. Again, it's really hard to draw these, but hey, it's a circle, right? Kind of. This is not quite right. Let's pretty that up a little bit. There we go. Anyway, it's good enough. It's a circle. We'll say it's a circle. So the distance from the center to any point along the circle is 4 here. Okay, and that's what defines a circle. Is it's just the set of all points that are equidistant from a center point. Okay, and I kind of mentioned this word already, but the distance that you're doing here from the center of the circle here to any other point on the circle, this is what's called the radius, okay? And we sometimes use r to represent the radius of the circle, okay? So that's how far you go from the center to any point on the circle. That's the radius, okay? Now, sometimes you could also run into diameter. Diameter is the distance across the whole circle, right? So it's 2 radiuses. But generally what you're going to be running into is the radius here. Okay, so what can I do with this circle here? What kinds of things can I do with this? Well, for one thing, it would be really nice if we could write an equation that would give us all the points along this circle so that I don't have to write out in words like, oh, I want a circle of radius 4, centered at 0, 0 every time I want to draw a circle. That I could just write down an equation and that would give me the circle. Okay, so that's what we're going to try and do right now is can we find an equation for this circle that we've drawn? Okay, well notice if you take any point along the circle, we'll call the point x and y, those are its x and y values at that point. Well, what you can do is you can draw kind of a triangle with that point, a right triangle. And you can change where this point is, but you'll always kind of be able to draw either a right triangle or just a straight line up to the point. Okay, and so what you can do to actually get an equation is if you kind of think of this right triangle here, well, this side here, the distance from the center point to the point on the circle, that's going to just be the radius, right? Because every point on the circle is the same distance away from the center. It's always the radius away. So that's going to be r. And then if you kind of look at your triangle here of these other sides, well, you've got like this side right here, this is going to be your x value of the point. And then this distance here, that's going to be your y value of the point, right? So you get this right triangle here, and so when you have a right triangle, we can use the Pythagorean theorem to find a relationship between the sides. So essentially, the formula we can get out of this is this side is x, this side is y, so we can do x squared plus y squared is r squared, okay? This is just applying the Pythagorean theorem to this right triangle here, okay? And it doesn't matter what x and y value I choose along this circle, right? This will always work. This will always be okay. So this is actually how we would get the equation of a circle centered at the origin, at 0, 0. Okay, so this would be a circle centered at 0, 0. Is x squared plus y squared is the radius squared. So in this case, with the circle that I've drawn here, my radius was 4. So the actual equation of the circle that I would have would be x squared plus y squared is equal to 4 squared, right? That was my radius in this case, so it would be x squared plus y squared is 16, okay? That would be the equation of this circle that I've drawn, okay? Now, before we get into doing some more examples of this, I do want to mention, right, this formula only works, right, if your center is at 0, 0. Your equation will be a little bit different if your center is somewhere else, okay? So if you move the center away from 0, 0, essentially it just shifts all your x and y values around. And so the equation for a circle in general, if you move your center around, just becomes x minus h squared, okay? You're shifting x, okay? Plus y minus k squared is equal to r squared. So it's the same kind of formula. You've got, again, x squared, y squared is r squared, but then you just have these shifts on your x and y here. So essentially, the center of the circle that we have written the equation for, the center of the circle is at h and k. Remember, because if you graphed a parabola, with the x minus h squared, that actually moved you to the right. It did the opposite of what you would think it would do. So this moves us to the right h, this moves us up k, so our new center is at h and k. And then the radius is r squared, is just r, right? So the center of this circle is at h and k, and then the radius is r here, okay? So this is the general formula you need to use to solve problems in relation to circles, okay? This is kind of where you want to do, or what you want to use. And essentially it's just the Pythagorean theorem is how you get it. But it helps us find an actual equation for the circle. Okay, so in the next video we're going to actually see an example of how we use this.